Okay, so 15.1 is over the introduction of rational expressions. We're going to go through the concepts of defining a rational expression, evaluating them, how do we restrict values, simplify, and then how to simplify a ratio of -1. So the first concept is the definition of a rational expression. Rational expression is the ratio of two polynomials, p over q, where q is not equal to 0. So all this is saying is that this is a fraction where p over q are numbers, but q cannot be 0 because we cannot divide by 0. So in these examples, two examples of rational expressions could just be the fraction 3 over 4, or we could have a polynomial over another polynomial, so 3x minus 6 over x squared minus 4. And this is mainly how we're going to see the rational expressions as polynomials, because we're going to learn how to simplify them by using the methods of factoring that we already learned. Okay. So in concept 2, we're going to evaluate rational expressions. What this means, it's going to give us a number to plug in. We're going to plug that in and see what we get. So for number 1, it says evaluate the rational expression for the given x values. So we have our equation x divided by x minus 3. So all it wants us to do is plug in the numbers for each of these parts. So for part A, we're plugging in x equals 6. So we have the equation x over x minus 3. We're going to plug in a 6 for x. So that means we have 6 over 6 minus 3. And then we simplify. 6 minus 3 is 3. So that means we have 6 over 3, which reduces to what? 2. So our answer here is 2. The reason we're practicing evaluating rational expressions is because when we are starting to look at graphing in the domain, we're going to learn which of these numbers that we plug in would end up restricting our domain. So here we're just practice plugging these numbers in. So for the next one, we're plugging in -3. So we have x over x minus 3. I'm plugging in a negative number, so I'm going to leave it in parentheses. So -3 over -3 minus 3. That gives me -3 over -6, which reduces to what? 1/2. Good. For part C, I'm plugging in 0. So I have x over x minus 3. Instead of an x, I'm going to plug in 0 for both of them. So 0 over 0 minus 3, which gives me 0 over -3, which reduces to what? 0. Good, because we can have a 0 in the numerator, but we can never have a 0 in the denominator. If we had a 0 in the denominator of any fraction, that fraction would be considered what? Undefined. So we have the last one where we're plugging in 3. We have x over x minus 3, which gives me 3 over 3 minus 3, which is 3 over 0. And we just said anything divided by 0 is called what? Undefined. We cannot divide by 0. So in the case of when we are getting to the point where we're graphing these functions and looking at the domain, that tells us that this x equals 3 is included or not included on our graph? Not included, because we got undefined when we plugged it in. Okay. Any questions on number 1? No, so we're just plugging in x values. Okay, concept 3 is over restricted values. So this is what we're talking about when we're talking about the denominator and how the denominator cannot be 0. So restricted values of a rational expression are values that make the expression undefined. So denominator equal to 0. Says how to find these restricted values. We find this restricted values by setting the denominator equal to 0 and solving. The restricted values are the solutions to that equation. So that's what it says in that red box, that we're going to take the denominator and we're going to set it equal to 0. Okay. So on number 2, what are we setting equal to 0? Good. 2y plus 7 equals 0 because that's the denominator. So then we're going to solve for y, and whatever number we get, that number is what's going to make this fraction undefined. So that means it's a restricted value. So I would subtract 7, and I get 2y is equal to negative 7. Then I divide both sides by 2, and I get y is equal to negative 7/2. And I'm just going to leave this as a fraction. So what this tells us is that if we plug in negative 7/2 into this problem, we would get a 0 in the denominator, which would make this fraction undefined. So this is a restricted value, because if we plug it in, we get 0 in the denominator. Denominator, which implies undefined. So if you're ever asked to find the restricted value, you set the denominator equal to 0. Restricted value. And these are going to come, these are going to be important when we start graphing these. Any questions so far? Okay, we're going to do the same with number 3. So what are we setting equal to 0? The denominator. And so we have x equals 0. Do we need to solve that? No, it's already solved. So that means our answer is x equals 0, and that is our restricted value. Meaning if we were to look at the graph of this problem, none of the values where x is equal to 0 would be, all those values would be undefined, not included. Okay, so sometimes it's just as simple as this because there's only one variable in the denominator. Okay, bless you. Okay, for number 4, what are we setting equal to 0?
2a minus 8.
Good. 2a minus 8 equals 0 because that's the denominator. So now I need to solve for a to figure out which number is our restricted value. So I'm going to add 8 to both sides, and I get 2a is equal to 8. Divide everything by 2, and I get a is equal to 4. So a equals 4 is our restricted value, because if we were to plug that back in, we would get a denominator of 0. Okay. So again, we're just setting the denominator equal to 0. Okay, in some cases, we can't just simply solve. So we have the equation a squared minus 25 equals 0. In this case, we can't just add 25 and take the square root. Because what does this part look like? A perfect square. And how do we factor a perfect square? Correct. So we're going to have 2 parentheses that are equal to 0. We take the square root of a squared, which is a, and then we take the square root of 25, which is 5, and 1 gets a plus, and 1 gets a minus. So from here, since this was something we had to factor, what are we now setting equal to 0?
A plus 5 and then A minus 5.
Good, so both parentheses we are setting separately equal to 0. So we have A plus 5 equals 0, and A minus 5 equals 0. So that means in the first one we would subtract 5, and we get A is equal to negative 5. Or we would add 5 in the other equation and get A is equal to 5. This tells us that instead of just one value that restricts that function, we have two values. So that means our A value cannot be 5 and it cannot be negative 5 because it would both make our denominator 0. Oh no, what happened? Sorry. Okay, so keep that in mind. If you see that square in the bottom, it's your hint to factor. Okay, that's your hint to factor. So let's look at number 6. So in number 6, we have x squared plus 9 equals 0. So there's that square there, so it tells us we need to factor. However, is this a perfect square? Yes or no? Why is it not a perfect square?
Because it has a plus instead of a negative.
Good, so this needs to be negative for a perfect square. Since it's not, then we just factor using the AC method to see if this is factorable. So that means if I was to rewrite this problem, since I don't have a b value, I would rewrite this as x squared plus 0x plus 9 equals 0. I'm writing the placeholder 0x as my b value, so when I do the a times c method, I can see that my b value is 0. So I would do a times c, which is 1 times 9, which is 9, and my b value is 0. So I'm looking for factors of 9 that when I add them will give me 0. Okay, so there's only two factors of 9, and that's 1 and 9 and 3 and 3. And of course, we could change them both to negative. If we add any of those, regardless if they were both negative or not, would we get 0? No, so this tells us that this is not factorable. So this is not factorable. And if we get something that's not factorable, that tells us that there is no restriction. Meaning I could plug in any number in for x, and I would never get 0 in the denominator. So if you go through the whole process, you try to factor it, it's not factorable, that tells us there is no restriction. No restriction. Which means if we were to graph this function, everywhere in the graph where we could plot an x or plot a y value, they would all be included. Any questions? Concept 4 is simplifying rational expressions. So we would simplify rational expressions the same way we would simplify a fraction. So for example, this is just the fancy definition for it. If P, Q, and R represent polynomials where Q and R are not equal to 0, then if we had the polynomial PR over QR, They both have an r in common, correct? That means we could cancel out those r's and just be left with PQ. So same thing when we were finding the GCF of those factors, when we took out the GCFs, we could end up having a number on top of another number and they would cancel. And that is when we're talking about rational expressions, since all of our equations are going to be a polynomial over another polynomial. Okay, so we might be able to factor out a GCF from both the numerator and the denominator, and then those would cancel. Okay, so that's what we're going to see here in these examples. So when we see the polynomials like this, the rational expression, the first thing we want to try to do is see if we can factor the numerator, and then see if we can factor the denominator. So first, looking at the numerator, we have 2p minus 14. Is there anything that we can take out from that problem? A 2. So if we take out a 2, we'd left with p minus 7. Okay, so that's us simplifying the numerator. So for the numerator, we have this on top. Okay, now let's do the same for the denominator. We have p squared minus 49. How could we factor this?
Perfect square.
Good, it's a perfect square. So that means I'm going to have p plus what number? 7, and then p minus 7, because perfect square means I have 2 parentheses. I take the square root of that number, and I have 1 plus, 1 minus. So this is the simplification of the denominator. So then if I rewrite this, I have 2p minus 7 over p plus 7, p minus 7. What can cancel out of that fraction? The p minus 7. So that means when I cancel that out, I am left with my answer of 2 over p plus 7. So I factor the numerator, I factor the denominator, I rewrite it with those factors, and I see if anything can cancel. Those are my steps. Any questions on 7? Okay. Let's look at number 8, and we're going to do the same thing. We're going to factor out the numerator first. So we have 5z plus 25. What can we take out? A 5. So we'd be left with z plus 5. Okay, so that is our new numerator. Now we're looking at the denominator. So we have z squared plus 3z minus 10. What method are we going to use to factor? Good, the a times c method. So I have a times c, which is 1 times negative 10. Negative 10. And then what's my b value? 3. So I need 2 factors of negative 10 that when I add them, I get 3. What would be those 2 factors?
Negative 5 and positive 2.
So negative 5 and positive 2 would be negative. The other way, yes. So positive 5 and negative 2 gives me a negative 10. But when I add them, I get a positive 3. So these are the factors I'm using. So then plugging them into my equation, I have z squared plus 5z minus 2z minus 10. From here, what factoring method am I using? Grouping. What can I factor out of the first one? A z, so I'm left with z plus 5. What about the second one? Negative 2 because I want my parentheses to match, so I have z plus 5. Meaning I have the factors z minus 2 and z plus 5. This is my new denominator. Okay. So now I rewrite that. So my numerator was 5z plus 5. And my denominator was that z minus 2, z plus 5. Is there anything that can cancel after I factored everything? Good, that z plus 5, that whole parentheses of z plus 5, because I have the same thing on the top and the bottom. Meaning I'm left with my answer of 5 over z minus 2. So I have 3 steps here. I factor the numerator, factor the denominator, put them together, see if anything cancels. Okay. Let's look at number 9. Number 9 is a little different because there's not something that we could factor separately, the numerator and the denominator. For this one, we're going to have to look at it as a whole. So looking at just our numbers, if we were treating this as a fraction, we could write this as 18 over 9, because that's our number part, times a to the 4th over a to the 5th. That's our variable part. All I'm doing is separating the numbers from the variables. How can I simplify 18 over 9? Good, it would become 2 over 1. So this one becomes 2 over 1. And how would I simplify a to the 4th divided by a to the 5th? Good, I would subtract those 2 exponents. So 5 minus 4 gives me 1, and where is that a going to go? On the numerator or on the denominator? Who has the most? The denominator, so this is going to become 1 over a. So I subtracted the 2 exponents, and this is just based off the property of exponents. If you need to go back and review, that wasn't, we didn't go over that in this course. And then whichever one has the highest exponent is where that variable goes. Okay, and then I just multiply across. So I have my answer of 2 over a. So in this case, this is something that did not need to factor the numerator and denominator separately. We had to factor it and reduce it as a whole. We're going to do the same thing for number 10. So let's go ahead and separate our numbers from our variables. So what is my first fraction going to look like? 15 over 9 times, what's my variable fraction? Q3 over Q2. Now that I have everything separated, we start reducing. What can 15 over 9 reduce to? 5 over 3, because we're dividing both of them by 3. And Q3 over Q2 is going to reduce to what? Q, and which one's going to get the Q, the top or the bottom? Why? Has the larger amount of Q's, so they get it. So this is Q over 1. So now that we simplified both the numbers and the variables, we put them back in one fraction, and we're going to get what? 5Q over 3. Close, because we're multiplying. 5Q over 3. We just multiply across. questions over 10?
On going back real quick to number 9.
Yes.
On that one, would it be improper to do 2 times a to the negative 1?
It would not be. You could. That would be the same answer. That's the same as 2a to the negative 1. But since we don't talk about exponents too much in this course, I wouldn't expect to see this because I wouldn't expect everyone to remember that concept. But if you wrote that, that is the same answer. It would be marked right. Typically, though, you don't want a negative exponent ever in your problem, just for the future. Okay, and then for number 11, how many fractions are we going to have? We're going to have 4 fractions, one for the numbers, one for the A's, B's, and C's. So what is our fraction for the numbers? 25 over 5 times, what about A's? 4 over A6. What about B's? And then C's? Good. Now we're going to reduce each of these separately. So all I did was take apart that large fraction, turn it into 4 mini fractions. Okay? How can I reduce 25 over 5? 5 over 1. How can I reduce a to the 4th over a to the 6th? Remember, we subtract the exponents. So just do the larger number minus the smaller number. So 6 minus 4 is 2. Which one is going to get a squared, the top or the bottom? The bottom, because it had a to the 6th, the larger amount of a's. So we have 1 over a squared. What about the b's? Who's going to get it, top or bottom? Top, and how many are they going to get? 1. And then what about the c's? Who's getting it, top or bottom? Bottom, and how many are they getting? 3. Okay. Now that we reduced each fraction, we are going to multiply all the tops and then multiply all the bottoms, and that's going to give us our answer, our reduced fraction. So what would we have on the top? 5b. What about on the bottom? A squared and c cubed, right? Because we still have that c cubed on the bottom. And everything's being multiplied, so I just write it next to each other. And this is my answer. You can do the same thing by just looking at this fraction here and reduce your numbers, reduce your A's, reduce your B's, your C's, once you get comfortable with the concept. You still have trouble with the concept, then I suggest separating it into each of the separate fractions. Okay. So that was it for concept 4. Concept 5 is simplifying a ratio of -1. So this is what's important here to remember. It says, remember that A minus B is not the same as saying B minus A. However, we can factor out a -1, and we could get that B minus A is the same as saying -1 times -B plus A, which is equal to -1 A minus B. So all this is saying here is that if we had something like 1 minus 2 over 2 minus 1, we couldn't say those cancel. We would have to do 1 minus 2, factor out a -1, so we get 1 minus 2 again. Then they would cancel. So we're going to see that here with some variables. So we have the numerator and the denominator, are we able to factor out anything from the numerator? 3. So if we factor out a 3, we're left with C minus D. On the bottom, we have D minus C. So we know C minus D and D minus C is not the same. So what do you think we should factor out of the denominator to make it the same? -1, because that's what this whole concept is about, is factoring out a -1. When we do that, we're left with -D plus C. Notice how just the signs changed. Now that we have this -D plus C, we know by the property of addition that we could just switch these two parts. So instead of doing -D plus C, we could do C plus -D, C plus -D, which is the same as saying C minus D. Okay, so actually let me write that out. So this is the same, saying C plus -D, which is the same saying C minus D. Of course, every time I'm not going to write out these steps. This is just to show you for the first time. Okay. Now that we factored everything that we can factor out, now we can cancel. And what would we cancel here? The C minus D's, right? Because those are the same, the C minus D's. So that means we would be left with 3 over -1, which just is -3. So the whole part of this concept here is that in either the numerator or the denominator, we're going to have to factor out a -1 in order for us to be able to cancel anything. Okay, let's do that same concept with 13. First, we check the numerator. What can we factor out of the numerator? A 2. So I'm left with t minus 6. And then since t minus 6 is not the same as 6 minus t, what do I need to factor out of the denominator? A -1. When I factor it out, now I have the same thing of t minus 6. Okay, so that's what you need to remember. If I factor out a -1, then my option is going to be equal to that numerator, and I'm going to be able to cancel. So here, what am I canceling? T minus 6, and I'm left with 2 over -1, which reduces to -2. Okay, I would have to see this step as your work. Okay, I would have to see that you're factoring out that -1 before you go and cancel.